Hey, since I'm not going to be in class tomorrow, I wanted to give you an opportunity to watch a video on the lesson you're going to be doing with a substitute. Today we're going to start into Chapter 2, and again, the homework isn't going to be due for another day or two. So we're going to be talking about notes number 6, if-then statements, and converses. And it looks like I have no idea how to form letters. I just have this bar that comes down when I'm writing, and it kind of covers up. It's like an arm guard, and it covers up what I'm doing, so it's kind of annoying. So I apologize for that. And this comes out of lesson 2-1 in the book. So a basic if-then statement, you've been already seeing some, but this is an example of one. If you study hard, then you will do well in school. Okay, and this is kind of when we overlap a little bit with other subjects, like in science. You start with an idea, and if that idea is true, then a conclusion will follow. We call the beginning a hypothesis, we call the end a conclusion. Now, this statement is called an if-then statement, so here's the weird thing. This vocab card has 3 names to it. These are called if-then statements because of the words if and then. They're also called conditional statements or very casually called a conditional. Okay, now that's all one big huge vocab card. Okay, so this is a statement with given information and a natural conclusion or natural outcome or consequence. Okay. Now, what some people might argue and say, hey, I study hard all the time and I don't always get an A on everything that I study, so I don't think this is true. Well, on an individual basis, you're right. It probably isn't, but you probably are not studying correctly. Even though you think you're spending a lot of time studying, you could be studying incorrectly and not actually making a big dent into the learning part. So the given information is called the hypothesis. So that's a new vocab word. And it's going to be the given information slash if part of a conditional. And then the next part, the conclusion, we could think about it as the consequence or the then part of a conditional. Now, one of the things is we do assume the hypothesis to be true, but sometimes the conclusion can be false. Okay? So now, if I take that if-then statement, that conditional, and I swap the parts, I've now created something called a converse. And a converse, another vocab word, is a conditional statement where the if and then parts are switched. So going back to our original statement, our converse would be if you do well in school, then you study hard. Okay. Now, sometimes the problem is some people do really well and they never study, and I'm sure you know some kids like that. Well, there's going to come a day when they're going to have to study to understand something. But for right now, it just seems like everything's a piece of cake to them, and you work so hard. And, you know, sometimes you get a C on a test and you feel so badly. Don't take it personally. So, what are some truths about conditionals and their converses? A conditional, and its converse can both are true, both be true. So the original conditional statement is true. With that hypothesis, that given information, the conclusion will always happen. The converse can also both be true. And we'll talk about that particular situation when both the conditional and its converse are both true. That's a new vocab word we'll talk about in a minute. You can have both are false. So, yes, we have this given information, but that conclusion doesn't have to be the case. And when we do the converse, again, the conclusion doesn't have to be the case. And then you can have one can have one be true and one be false. So those are be your only options here, obviously. Okay. So here's what you have to do. Based on the given piece of information, the if part, if you can come up with one instance where the conclusion doesn't come true, that's called a counter example. We talked about that in algebra, especially when we were studying properties, as the algebra kids are now. And a counter example is an if-then statement so a conditional, where the hypothesis is true, but the conclusion, let's put it's false. One counterexample disproves. A statement. So in other words, all you have to do is find one conclusion that doesn't go with the hypothesis, and that's all. Now you can just say that this is a false conditional. Okay, so you only need one. All right, so let's go back to that idea I said, well, what if a conditional and then its converse both are true? Well, that is called a biconditional. And a biconditional is a statement containing this phrase. I'm going to put it in a different color. If and only if, which gets abbreviated to IFF, and that's perfectly acceptable. A statement containing this phrase, if and only if, or IFF for shortcut, and oops, sorry. So it contains this, and then and is formed when both a condition or conditional and its converse are true. Okay. So here's our conditional. I'll just use C to represent conditional, and it's going to be if 4x equals 20, then x equals 5. And we would say true. Then we have the converse. If x equals 5, then 4x equals 20. And that would also be true. So we can write it as a biconditional. And I usually go back to the original conditional and use it as a starting point. So 4x equals 20, and here comes that abbreviation, if or only if x equals 5. And then that would also be true. So it's a situation where things are also always going to be true. Now, one thing that we study is that all, and I'm going to write this in red, all definitions can be written as a biconditional, or as biconditionals. Okay, so that's kind of important to understand. So I'm going to do one example of that on the next page. And then I'm going to make you work a little hard by making sure you review in your textbook. So here's a definition. Congruent segments are segments that have equal lengths. Notice that you don't see ifs and thens It's not written in a traditional conditional format, so it looks a little different, but this is true. Congruent segments have equal lengths, bottom line. So here's how we would write the biconditional. Segments are congruent and here comes that little abbreviation, if and only if their lengths are equal. So the language isn't identical to what we began with, but it's close enough. It'll get by. Okay, so I have one more thing I'm going to put on here for you guys to look at, and that is looking at, I'm going to put this again in a, I want you to look at the top of page 34, and it's going to be understanding the difference between the hypothesis and the conclusion. And so I'm just going to use their coloring just so that you'll be able to understand that when you see P, it's referring to the hypothesis. And then when you see Q, it's talking about the conclusion. So they're writing their very simple outline of what a conditional statement looks like as if P then Q. But what I want you to pay attention to is how there's different ways of writing a conditional statement, and it's not always in the if-then form, okay? So these show you, I think there's 4 variations. So different ways to write conditionals. So I want you to really pay attention to it, because that's part of what your homework is to ascertain what is the hypothesis and what is the conclusion. Everybody thinks that if is the key word. Sometimes what comes after if could be a conclusion, the way that the sentence is written. And sometimes if isn't part of the conditional at all. So that's what I want you to do, is spend a little bit of time looking at the top of page 34 to see the different ways to write conditionals. All right, good luck.